To set up a multifunction timer to execute the flash function, a technician must first choose the correct function and then set the delay period. Here's an example of a multifunction timer with both a two-terminal coil and an additional auxiliary controlling input. This particular manufacturer does not make use of the auxiliary controlling input to initiate the flash function, but rather initiates it anytime the coil from A1 to A2 is energized. Additionally, this manufacturer starts the symmetric flash function with an on-delay period. A timing diagram of this timer executing the flash function looks exactly as I've illustrated. This particular timer can perform 8 different functions, A through H. To set this particular multifunction timer to perform the flash function for a period of 5 seconds, a technician will rotate the function selector to function D, the flash function as illustrated in the table. Then a technician would choose an appropriate delay. This multifunction timer has a symmetric flash function that necessitates only a single delay period. This particular manufacturer necessitates a 2-step process to adjust the delay period. First, select the range, then adjust the range percentage. The range selection presents possibilities from 1 second up to 100 hours. Percentage can then be used to fine-tune the delay period inside this range. For example, 50% of 10 seconds would be a delay of 5 seconds. Note this timer has 2 indicator LEDs, one that indicates when the device is powered up from A1 to A2, and another that indicates when the outputs are in their activated state. You know you set up the flash timer correctly if you energize the coil, wait 5 seconds, and then see the output change states. While the timer coil remains energized, the associated contacts continually change states every 5 seconds and, as the name implies, flash, repeat, or recycle. When the timer coil is de-energized, the associated contacts immediately return to their deactivated states. Troubleshooters take note. A multifunction timer executing the right function at the wrong time needs to have the delay adjusted. In contrast, a multifunction timer executing the wrong function at the right time needs to have the function adjusted. I like to say a misinterpretation of functions is a rare occurrence, but it isn't, and you need to be aware of this possibility. You note timers executing solely the on delay or solely the off delay sometimes their own schematic symbols. However, timers executing the flash function are often represented schematically as regular normally closed or regularly normally open contacts. The documentation associated with the ladder logic diagram should clearly indicate that these contacts are performing the flash function. Let's now move on to the remaining topic of this lecture, putting a timer executing the flash function to use. The flash function is characterized by continuous periodic oscillation between the deactivated and activated states while the controlling input is energized. For these examples, we'll make use of a multifunction timer that is symmetric in nature, does not require the use of an auxiliary controlling input, and starts the flash function with an on-delay period. The classic introductory example of the flash function is the time-delayed response of pilot lights. The 3-wire control circuit in rung 1 and 2 serves to simultaneously de-energize the coil of a regular control relay, CR1, and the coil of timer relay, TR1. Contact CR1A, associated with regular control relay CR1, serves only as a holding contact, allowing the circuit to maintain the last asserted state. Rung 3 contains a normally open contact TR1A, associated with timer relay TR1 executing the flash function in series with a red pilot light. Rung 4 contains a normally open contact TR1B associated with timer relay TR1 executing the flash function in series with a green pilot light. Let's assume the timer executing the symmetric flash function is set to execute a 5-second delay. Note the start state of this system is red light on, green light off. When an operator presses start, the coil of control relay CR1 and the coil of timer relay TR1 are both energized. Contact CR1A immediately switches to the activated closed state and establishes a holding circuit. The holding circuit allows an operator to release the start button. In contrast, the contacts associated with timer relay TR1 executing the flash function do not immediately change states, since this manufacturer initiates the flash with an on-delay period. TR1A remains closed and TR1B remains open. Only after the on-delay period of 1, 2, 3, 4, 5 seconds does TR1A open and TR1B close. The red light turns off and the green light turns on. While the coil of timer relay TR1 remains energized, the associated contacts periodically oscillate between the activated and deactivated states. After a 5-second wait, the contacts TR1A and TR1B flip-flop. the red light turns on and the green light turns off. After another 5-second wait, the contacts TR1A and TR1B flip-flop again. The red light turns off and the green light turns on. As the title implies, the associated contacts are periodically flashing, repeating, or recycling when the controlling input is energized. When an operator presses stop, both the coil of control relay CR1 and the coil of timer relay TR1 are de-energized. Contact CR1A immediately returns to the deactivated state and removes the holding circuit, allowing an operator to release the stop button. Additionally, the contacts TR1A and TR1B immediately return to their deactivated states. The TR1A contact recloses and the TR1B contact reopens. The red light turns on and the green light turns off. We've returned to the start state of our system. The flash function can be put to use in many ways, the most obvious one being to create a super annoying warning strobe anytime a particular process is in the run state, serving to notify affected personnel that certain safety precautions must be taken. For example, consider the ladder logic diagram controlling one such system that alternately blinks a yellow light whenever a motor is energized. By all means, pause the lecture and see if you can determine how a timer executing the flash function makes this possible. Assume the timer is executing a 1-second delay. If you're tracking, you should have observed the following behavior. When an operator closes start, the F contactor coil and the coil of timer relay TR1 are simultaneously energized. The associated F contacts change states. The F1 holding contact closes and allows an operator to release the start button. The primary F contacts close and the motor springs to life. Additionally, the contacts associated with timer relay TR1 initiate the flash function. Following an on-delay period of 1 second, TR1A closes and turns the yellow light on. 1 second later, TR1A opens and turns the yellow light off. 1 second later, TR1A closes and turns the yellow light on. 1 second later, TR1A opens and turns the yellow light off. You get the picture. When an operator presses and releases stop, both the F contactor coil and the coil of timer relay TR1 are de-energized, and their associated contacts immediately return to their deactivated states. The F1 holding contact opens, and the F primary contacts open. The motor free spins to a halt. TR1A contact opens, and the yellow light turns off. We're back to the ready start state of our system. Besides making stupid lights blink, the flash function can also be used to time-share a load between two motors. Time-sharing is to ensure one motor isn't routinely tasked with excessive labor while another sits idly by watching all the work. Does this remind you of your relationship with a certain lab partner? A properly time-shared system ensures ordinarily idle system is also routinely exercised and the work equitably distributed. For example, consider the ladder logic diagram of one such system that alternates the load between two motor-driven pumps whenever liquid level in a tank triggers a float switch. By all means, pause the lecture and see if you can determine how a timer executing the flash function makes this possible. Let's assume the flash function is set to 5 minutes. If you're tracking, you should have observed the following behavior. When liquid level in the tank rises enough to trigger float switch 1, the coil of timer relay TR1 and the A contactor coil are simultaneously energized. The timer relay initiates the flash function, starting with an on delay for this particular manufacturer. TR1A remains closed and TR1B remains open. The contacts associated with the A contactor coil, however, immediately change states. The A primary contacts close and motor A springs to life. Assuming pump A has not evacuated the tank within 5 minutes, the contacts associated with timer relay TR1 change states. TR1A opens and de-energizes the A contactor coil. The A primary contacts open, and motor-driven pump A free spins to a halt. TR1B closes and energizes the B contactor coil. The B primary contacts close, and motor-driven pump B springs to life. If float switch 1 is still activated 5 minutes later, pump B turns off and pump A turns on. If float switch 1 is still activated 5 minutes later, pump A turns off and pump B turns on. You get the picture. Only when float switch 1 opens up are both the coil of timer relay TR1 and whichever pump happened to be running at that time de-energized. For the simple example, note that the series nature of the normally closed overload contacts serves to de-energize both motors whenever one motor experiences a sustained overload condition. Even though the other motor may be fine, this system would still cease pumping the tank. For this reason, if this was some mission-critical task that must be accomplished, it would necessitate a significant upgrade in the existing ladder logic to timeshare while both motors are available, and shift solely to the available motor if the other ever entered overload conditions. Astute and motivated viewers may wish to explore the possibility of creating a ladder logic diagram that does so, also utilizing the flash function. Alright, that is that for this lecture. In conclusion, this lecture took a brief look at multifunction timers performing the flash, repeat, or recycle function. We introduced the flash function, reviewed general timer functions, learned how to set up an example timer relay to perform the flash function, and finally employed a timer executing the flash function in several illustrated examples. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource. Be sure to check out the Big Bad Tech channel for additional resources and updates.